Yeah, but first I have a couple other things I need to do. Okay.
What am I doing?
We're going to do a practice problem right now. So those of you that got the quiz all right, God bless you. You're just going to have to endure this because we're going to do another one now for those people who didn't get it all right. All right, here we go. We are going to find the vertex by completing the square. So the first thing, there are two things we know this that has to happen before we can complete the square. That guy has got to be gone. And that guy has to be moved. Now it is completely ready to complete the square, right? So here we go. Half of 8 squared. Add it to both sides. This side is my perfect square. This side, I could add those together, and then I can pull out my 4. And from that, I can tell that my vertex is 4, 1. Now, if you preferred, at this point right here, you might have added 4 to both sides. This is the cool thing about math. There's always options. And then divided by 4. Either way you do it, the vertex is at 4, 1. Okay? Now, you might be saying to yourself, you know what, Mrs. Ford, I don't really care that I don't know how to do this because I know how to do negative b over 2a, and that will get me my vertex. And you're right. But this process is how we put ellipses and hyperbolas also into standard form. And there are no shortcuts with those. You have got to know this process. You've just got to be able to do this. It's important for your future success.
For the negative b over 2a, does x squared still have to be 1?
No. There are no restrictions on that. A can be anything. Okay, so that's that. Now, I want to do this. I want you to get out a half sheet of paper, notebook paper, please. Yeah, spoon a piece, that's a great idea.
That's all. No, mine takes it.
That's okay, I'll just show that.
Oh, God bless your heart.
Yeah, I had it there. And I had it there. We were racing, so I kept it and I was wrong. Oh, yeah.
Oh.
Okay, your notebook should be put away. I want you to take a couple minutes and get this guy sorted out. You know how to do this. This is not notes. I don't want you looking on anybody else's paper. I want you trying to figure this out. Put this away.
How does it work? How does it work?
Causes a drop.
Causes a loss. right, David. You sell 100 cookies for $1 each. Every 10-cent increase causes a loss of 5 sales. Find the optimum price. Let's get it done. Everybody should have an equation written at this point. Right? So who feels confident in the equation you have written? Yeah, go ahead, put it on the board, would you? Go over on that board, we'll take it. You're gonna be on video. Oh, can you do the first, that's okay. Go ahead and write that, but then can you write your first equation? The first, because you didn't start with this. Yeah, what was the first thing you had? Okay, now right under that, what did you have? Yeah. You did the flip done. I don't know if the multiplication's right. Anybody verify that multiplication, is that right?
Yeah.
All right, let's talk about that, make sure everybody's got that equation. If you do not have that equation, you need to pay really close attention. I love the way he did this. He started, this is all about making money. This problem is all about making money. He said, here's how I make money. I sell 100 cookies at $1 each, so I'm making $100, right? But now I'm going to make some changes. What am I going to do? I'm going to raise my price. I'm going to raise my price 10 cents a time, and X is the number of times I raise my price. Right? So $1 plus 10 cents X will represent the cost of the cookies. But every time I raise my price, I lose some sales. So I started out selling 100, but I'm going to lose 5X. Then he foiled that and got this, which you all said was correct. Okay, Jack?
What happens when the X squared is positive?
You got a bad situation because, oh, that X squared is actually negative. Why is it necessary if I am trying to maximize, why is it necessary that that X squared be negative?
So that you have a maximum point.
Yeah. Otherwise, your parabola is not good. If your parabola looks like this, you don't have a maximum, do you? You have a minimum. Okay, who can find the optimum price now then? Who feels confident in your answer with that? Okay, Jack, would you come up and show? Come show your work. Jack, my man. Is Mr. Brown your English teacher?
Yes.
So you must be a junior?
Yeah.
Yeah? You want to turn around and show the seniors what sweatshirt you're wearing?
Boo.
That's a BT, man. I can't stand that. It's my pet peeve. It's rude. I really love you, Jack, but really, you're not a senior. Okay, he got 5 price changes. Negative B over 2A, he got 5. Is that right? Everybody agree, 5? So how did he get the price to be $1.50? That was the question. If you answered 5, you're not going to get full credit because you didn't answer the question. How did he get $1.50? 5 price changes at 10 cents each would be 50 cents added on to the original dollar. Anybody have a question about that? Elise?
Shouldn't both the 5 and the 1 be negative?
The 5.
Because it's negative 0.5, so when that's multiplied by 2.
What 5? This 5?
But no, both in the
The
fraction,
negative.
the 5 and the 1 should be negative.
Yes.
Oh, these two?
Yes.
Yeah. Negative B over 2A would be, yeah. I don't know if he just canceled those out or what. Yeah, they are both negative. So 5, X turns out to be positive 5. Anybody else? All right, now turn it over and we're going to do it for real. No, wait now. You had a chance to ask. Time to do it for real. Okay, this morning they got all bent out of shape because they didn't want to do cookies. Do you have a preference to what you want to do, or shall we do cookies again? Oranges? Interesting. This morning we did bananas. Okay, we'll do oranges.
We're helping.
Okay, you're gonna sell 1,000. This is for real. Turn your paper over. We are not talking or sharing. There should be no notebooks open. This is a real quiz. So we're going to sell 1,000 oranges for 50 cents each. Every 10-cent increase causes a loss of 40 sales. Find the optimum price. So it's exactly the same scenario, different numbers. By the way, I found the contact in here yesterday. Anybody lose it? Seal. Need some fresh contact. effort. Make sure you answer the question. Okay, one more minute. Okay, I want your pencils down. All pencils down. Here's how this is going to work. Riley told me he was comfortable and confident with his answer. So Riley's gonna come up, put it on the board. If he gets it right, you all get it right. If he doesn't get it right, then I collect everybody's papers and grade them like normal. So the pressure's on, big guy. You can do this. Oh, yeah. No, all your work. Nobody's writing, we're all done writing. We're gonna turn in what we've got, unless Riley gets, hey Riley, what you doing on this board over here since we're videoing? Mm-hmm. Yeah, so if you miss it, you're on video. So he is starting with the basic premise of 1,000 oranges at 50 cents each. He says he's losing 40s and gaining 10 cents. Losing 40s on the oranges, gaining 10 cents on the price. Do you think Riley's on the right path with his equation? You be paying attention, so it's never something you will be on your own.
Everyone cool with that?
Hey, you just write down what you got. This is a good project.
Doing good.
What do we think? I think Riley just earned you all a perfect score. Good job, okay. 10, negative B over 2A worked out to be 10. That means 10 price increases. Each price increase is worth 10 cents, so 10 of them would be $1. Added on to the original 50 cents. Kids, you need to be able to do this. All right, and we may not do another one until you see it on a test or quiz, so this is your last opportunity. Everybody's got to be able to write this equation. I think you can get it from there, but you've got to be able to write that equation. Okay, all right, well today we're going to spend a little time talking about power functions. And the principle behind this, is pretty simple, and you've already talked about a bunch of them. For example, we've already talked about x squared. We've already talked about x cubed. We've already talked about root x, which is x to the 1/2. Square rooting is halving. And we've already talked about y equals 1 over x, which is x to the -1st. So we have already discussed some basic ideas behind all of these power functions. A power function is simply a function that's x raised to a power. Okay? A non-zero power. Anything but 0. So we can raise it to fractions, we can raise it to negatives, we can raise it to regular whole numbers or natural numbers, anything but 0. Okay? Now let's talk about what the shapes of these things are, because open up your book and look at page 197. Everybody's on page 197. And we're looking at those pictures right there in the middle that go with exercises 37 to 42. And our job is going to be to match the equations to the graphs. Okay? Now I think some of this you can already do. Let's restrict ourselves just to quadrant 1 for a moment. Because frankly, the exercise only uses 1 and 4, right? So let's just start with quadrant 1 for a moment. What does this look like? It's a parabola. So in quadrant 1, it would look like that, right? If I only drew the part in quadrant 1. Now take your calculator out. I want you to do something for me. Set a standard window and graph y equals x to the 4th. Just in a standard window, y equals x to the 4th. What'd you get? You got a parabola. Now, with that one, graph y equals x squared. So put y2 is y equals x squared and graph that one. They aren't exactly the same. It didn't come out on top of each other, right? They have the same shape, but the x to the 4th is skinnier. And that should make sense to you, because when you raise numbers to the 4th power, they get bigger faster than they do when you square them, right? That makes sense. What do you think, without graphing it, what do you think x to the 6th looks like? It would be even skinnier, but it would be the same shape. Very important concept that we're going to use a lot in the coming weeks. If you have an even-powered polynomial, x squared, x to the 4th, x to the 6th. It starts up and ends up. Even if you put in some other gunk. So even if we put in, a bunch of other stuff, it's going to start up and end up. Now it may have some wiggles in there, but its end behavior is going to be starting up and ending up. Unless you put a negative in front of it, and then it will start down and end down. So this would be the picture of a positive x to an even power, and this would be the picture of negative x to an even power. Would you agree with me? If we're looking at just basic shape. Okay, now, let's talk about this guy. What does he look like? Y equals x cubed. Well, you know what he looks like, right? He looks like this. Now, wait a minute. In the first quadrant, if we only look at the first quadrant, does that look kind of similar to what the even one looks like? It does. The difference is the even one is in quadrants 1 and 2, and the odd one is in quadrants 1 and 3. But basically, the shape's the same. Graph x to the 5th. Does that have the same kind of shape? Does x to the fifth look like x cubed, I mean? Yeah. Now, what can you tell me about odd-powered functions? They don't start up, end up. Odd-powered functions start down, end up. Unless you put a negative on them, and then they start up and end down. So if you were walking down the hall and you found something that looked like this, you wouldn't necessarily know its equation right off the bat, but you would know that it is an odd degree. It would be x to the third or x to the fifth or something like that, because it starts down and ends up. All right. All right, what about this? What does this one look like?
Starts and then just goes like that.
It just is that, right? Is that okay with everybody? It looks like this. That would be your rooting thing. What if we did the cube root? Type into your calculator y equals the cube root of x. And you can either use your cube root button or you can raise it to the 1/3 power. If you raise it to the 1/3 power, please make sure 1/3 is in parentheses.
Where's the cube?
It's in the math menu. Now, I'm interested only in the quadrant 1 part. It's going to graph more than that. But does the quadrant 1 part kind of look like this? It should. The whole thing should look like this. But it should, you should have that same basic shape in quadrant 1. Okay, so what's the moral of that story? Well, remember, in a minute we're going to be matching. If we get something that looks like this, the coefficient's positive, and it's x to either an even or an odd power. Just x to some power. This is going to be x to a fractional power. What about this one? What does this look like? That's one of your BFFs. That looks like this, doesn't it? When you raise x to a negative power, that throws it to the denominator, which means you're going to have asymptotes, right? So if I see this picture, I'm thinking 1 over x, or x to a negative number. Let's see if we can match them up now. Oh, by the way, they throw in this. What's that?
Y equals x.
That's y equals x. So that's a power function. That's x to the first. He's kind of in his own category. X to the second, x to the third, x to the fourth, they're kind of all together, but x to the first is on his own. All right, so let's match them up. Look at that first equation, number 37. It's x to the fourth, which means it should look like this. But what? It has a negative coefficient, which is going to drop it down like this. You with me? So that first one, number 37, would be G. You in agreement? Okay, take a minute, see if you can finish the rest of those. See if you can match them up, knowing what you know. Marita?
Like I did something on my calculator, so now like the exponential doesn't work.
What were you
like-
doing on your calculator, honey?
Like I dropped it, and then I clicked OK.
Has it always looked like this over here? Because that looks very strange to me.
No.
And you don't know what it said when you clicked OK?
It like brought me up to like the text symbol.
The button I'm looking for. right, how are you progressing here? You doing okay? What do you think about 38? A. Very, very good. Why? 38 is A. Why? The exponent is negative, which means it's like a reciprocal. It's 1 over x. How about 39? D. It's a fractional power. This is your root. This is your root shape. It's a fractional power, so that's your root shape. What about 40? You got to be careful with 40. It has a negative coefficient, which means it's going to be in quadrant 4. It's going to be flipped down. Notice that the power is big. It's a fraction, but it's bigger than 1. So it functions actually like squaring does, or cubing or something. So which one was that, 40? Number 40 is actually G. I know why you're confused by that. I get it, but the power is bigger than 1. 41. It would have to be H because it has a negative coefficient. And what about 42? D. It's a root, and the power is less than 1. Make that a 5/3, and it's a different curve. But a 2/3 functions just like the radical. Okay? Well, there's one more thing we need to talk about real quickly, and that is direct and inverse variation. Can anybody explain to me the difference between direct variation and inverse variation? You studied these last year. That was last year. I know you're supposed to remember it though. Riley.
Isn't it like y equals kx or something like that?
Okay, that's actually the equation for direct variation, but can you tell me what direct variation is? What does it mean when we say y and x vary directly? What does that mean, Jack?
It's like when y equals something, then x will equal something else.
True, but that's true of inverse variation too. Tell me about the y and the x, the relationship to each other. No, they're not equal to each other. Grace?
One wants more into it.
As y increases, x will increase.
There you go. That's it right there. If things vary directly, then as one goes, so goes the other. So in other words, if x is getting bigger, y is getting bigger. A perfect example of that is, I used it this morning, when I go to the store to buy bananas, let's say Caitlin